All right, so this unit, all about triangles, all about angles. So we're doing a really big review of geometry today, and then that'll come in handy later on as we get to the harder, more difficult types of problems. So angle of elevation, the angle measured from the horizontal upwards. Anytime we're given the angle of elevation, we'll always draw a horizontal line and use that angle going up. Angle of depression is kind of the opposite, the angle measured from the horizontal downwards. So if we're like above something and looking down, generally that's how we use the angle of depression there. In either case, we'll usually sketch in a horizontal and then go either up or down. I think that's the easiest to approach a problem like this. Okay, so number 53 in the textbook says this. Suppose we're headed towards a plateau that's 50 meters high. If the angle of elevation to the top of that plateau is 20 degrees, how far are we from the base of the plateau? So the first thing we're going to do for all of these cases is we're going to draw a diagram that sort of represents what's going on. So we have some plateau. And we know that the plateau is 50 meters tall. Right, comes from this piece of information here. And we also are told that the angle of elevation to the top of that plateau is 20 degrees. So we are standing, let's say, over here. And we are told that the angle of elevation to the top of that plateau is 20 degrees. All right, that would be the angle of elevation there from the horizontal going upwards. And then the last thing we want to know is how far we are from the base of the plateau. So we're solving this distance here, the base of that right triangle. We're going to assume that plateau makes a 90-degree angle with the ground. Okay, what do we have? Well, we have this angle 20 degrees. We have the side opposite and we have the side adjacent. We don't know what the side adjacent is, but those are the three pieces of information we've got. An angle, a side opposite, a side adjacent, which means we're going back to tangent. So remember, think back to geometry with SOHCAHTOA. Tangent is always opposite over adjacent. So we write this as the tangent of 20 degrees is equal to 50 over d. We can then solve for d, right? That distance there. The distance is equal to 50 over the tangent of 20. This is where we're going to type it into our calculator. So make sure you guys have your calculators in degrees today. We're going to round to the nearest hundredths place like we're going to do in the homework. So 137.37 meters is how far away we are from the base of the plateau there. Okay, hopefully not too difficult. Hopefully a pretty big review of geometry there. Units are important. You will lose points if you don't have units on your test, right, as your answer. So get used to writing units there, you guys. All right, stop me if you've got questions. Moving on. We've got the situation, finding the angle of elevation of the sun. So we're told at 10 a.m. on April 26, 2007, we're almost exactly, I don't know, 13 years out from that, 14. A building 300 feet high casts a shadow 50 feet long. We want to know what the angle of elevation of the sun is. Okay, so the angle of elevation of the sun or to the sun is how I like to say it, would be from the horizontal up to the sun. So we're solving for that theta there. So again, diagrams are really helpful. It kind of helps you picture what you need to solve for as well. Okay, what else are we told about this problem? Well, we're told that the building that is 300 feet tall casts a shadow that is 50 feet. So the building itself is 300 feet tall. The shadow is 50 feet. We've got another right triangle going on. Right? This is not the Leaning Tower of Pisa. We're going to assume that the building makes a 90-degree angle with the ground. All right, so again, what do we have? Well, we've got a right triangle, we've got an angle, we've got the side opposite, and we've got the side adjacent. So again, we're going to use tangent here. The tangent of theta is equal to opposite over adjacent. Now, our goal in this problem is to solve for theta though. We can do that. We know we have those inverse trig functions to allow us to do that. So in order to get rid of tangent on the left-hand side, we're going to take the inverse tangent. And you guys are just going to type that into your calculator. Again, we're going to be in degrees here. The inverse tangent of that is 80.54 degrees when we round. Okay, one more like this, and then we'll get to the last and hardest example today. Okay, so the bottom of page 2, we're going to go to example 71, and then we're going to go back to a previous problem in the textbook. But let's talk about this one first. So we've got Mount Rushmore here, and we're told this: to measure the height of Lincoln's character on Mount Rushmore, 2 sightings 800 feet from the base of the mountain are taken. If the angle of elevation to the bottom of Lincoln's face is 32 degrees, and the angle of elevation to the top of his face is 35 degrees, we want to know what the height of his face is. And I think I've actually Googled this in past years, and it's pretty accurate, we think, according to the internet. But we can do another Google search in a minute. Okay, so let's draw a diagram first, and then kind of see how that's going to help us solve this problem. So first thing I'm going to do, we are trying to measure the face of Abraham Lincoln on Mount Rushmore. Okay, there you go. I'm definitely not an artist here, you guys. And what we're told is we take 2 sightings 800 feet from the base of this mountain. So let's say we're sitting over here. And we are 800 feet away from the base of the mountain. And Lincoln's face is kind of up a little bit higher. We take 2 readings. The first we take to the bottom of Lincoln's face. So the angle of elevation to the bottom of Lincoln's face, right there, is 32 degrees. And then we're also told the second measurement is the angle of elevation to the top of Lincoln's face. And that whole angle is 35 degrees. So be careful here. The 35 degrees is that entire angle from the ground moving up, right? From that horizontal ground going up. And we want to know what the height of Lincoln's face is here. So I'm going to label a couple of things. We've got a couple of right triangles here. We've got this smaller one. I'm going to call the height of that smaller right triangle Z. And then we've got this bigger right triangle. I'm going to call the height of the bigger right triangle. I don't know, you can call it whatever you want. Call it X. Okay, and what I do know is that the height of Lincoln's face is equal to X minus C. Okay, so before I solve this, think about how you guys would approach a problem like this. It's harder than the last 2. There's a couple of more complex things we've got to do here. But think about how you guys might approach that before we go into solving this together. I'm going to create a little bit more space here. Okay, in all cases, with both of those triangles, the smaller one and the larger one, we have an angle, we have the side opposite, and we have the side adjacent. That 800 feet, the base of that triangle, those are the that's the side length adjacent. So I can set up 2 equations here. the tangent of 32 degrees, that's our smaller triangle, is equal to z over 800. And I also know, using the larger triangle, that the tangent of 35 degrees is equal to x over 800. So we can use both of these equations to solve for z and x, and then we can find the height of Lincoln's face here. So z is equal to 800 times the tangent of 32 degrees. X is equal to 800 times the tangent of 35 degrees. And so my goal here, you guys, is to plug into my calculator only once. If I can do it just with one single calculator calculation, that's going to make sure that I'm not rounding anything before I get my final answer. All right, so the height of Lincoln's face then is going to be x minus z. It's 800 tangent 35 minus 800 tangent 32 degrees. Just plug that into your calculator. All right, units here are feet. Lincoln's face is 60.27 feet tall. It's a pretty big face. All right, any questions on that? We're going to get to one more concept today, and you guys are going to work your homework. Okay, turn the page over in your student note packet. At the top of page 3, we're going to take a few notes, and then we'll do the last problem from the textbook we're going to work through together. Okay, if there's anything you guys are going to take away from today, it's this. So please be careful. If you've got any questions, ask them as soon as we're done so that you are good to go with future problems that you guys need to use this on. We're going to look at all of the different ways we're going to measure angles in this unit. We're going to change it up a little bit from what we know so far. Okay, so this is really an important concept. Again, let me know if you guys have any questions on this. So on the top of page 3 of your student note packet, in the upper left-hand corner, we have a space for standard position. So when we're measuring an angle in standard position, if you have a problem for homework or problem on the test that says an angle measured in standard position, that is an angle measured using like the unit circle values, right? Or how we measure angles on the unit circle. That means that 0 degrees is always the positive x-axis, and we always measure a positive angle going counterclockwise. So in the upper left-hand corner of your student note packet, if you guys want to just draw an x and a y axis really fast, and then just mark the 0 degrees is on the positive x-axis, and we measure an angle positively going counterclockwise. That'll just be a nice diagram for you guys to reference there. So again, using the same angles we see on the unit circle, the positive y-axis is 90, the negative x-axis 180, and so forth. So an angle in standard position, it comes from the same way we measure angles on our unit circle. So that's what we've been focusing on so far this whole year. That's how we measure angles. To this method, though, we're going to add 2 more today. And we will use both of these as well as we go through the rest of this unit. So the next 2 methods are both called bearing. But I'm going to break it up into 2 different types of bearing. So bearing method 1. I call this method the true north method or the compass method. Right? Bearing is going to use direction. So what I mean by that is northeast, southwest. All right. So think back. I don't know. When do you learn this? Elementary school? Northeast, southwest. Never eat soggy wheat. Right? Going around the circle. Got to remember where North, south, east, and west are. But north for bearing method 1 will always be at the top. Okay, always that positive y-axis. Now, north is always then in this method 0 degrees. So we're now starting 0 degrees at the top, right? Pointing upwards. We measure a positive angle going clockwise now then. So if you have a problem that says you have a bearing of 40 degrees, a bearing of 40 degrees means we're going to start at the North Pole. We're going to move clockwise 40 degrees. So 40 degrees, a bearing of 40 degrees might look like that. So totally different than what we've been learning with the unit circle. Our starting place is different, our direction is different, but really important to remember here. Okay, the last one is bearing method 2. This one's a little bit different. It's still bearing, which means we're going to still start by labeling the directions, north, east, south, and west. In bearing method 2, just like bearing method 1, we will always start either at a pole, so north or south pole though this time. All right, so in bearing method 1, we always start at the North Pole. Bearing method 2, it's going to be the North or the South Pole, depending on the measure we're taking. So if we take a look at this example here, you guys just draw that in. We want to draw the bearing north 27 degrees west. Okay, so here's how we're going to approach this. North is the pole that we're going to start on here. So we are going to start up here at the North Pole, and we are going to go 27 degrees towards the west. So that's how we read that. We start at the North Pole and we move 27 degrees towards the west. So 27 degrees towards the west here. Do my best to guesstimate. Might look something like this, right? Start at the North Pole, go 27 degrees towards the west. Okay, example 2 for this one, try graphing this first and then check your work. South 47 degrees east. Where do we start? Where do we move towards? So in bearing method 1, that would be like negative 27 degrees. Good question. Usually with bearing, we don't see negative angle measures, rarely. Right, south 47 degrees east, what is that going to look like? All right, this time in example B, we start on the South Pole. So we're starting down at the negative y-axis. We're going to move 47 degrees towards the east. So south 47 degrees towards the east, that's just a little bit past halfway. This would be that 47-degree angle. Kayla, question?
Yeah, I had actually 2 questions, but they're both about the bearing method.
Yep.
For number 1, is the positive like to 180? Does it go all the way to south, or is it like?
Yeah. If you were graphing 180 degrees on bearing, it would be south, right on the South Pole.
Okay, and for bearing method 2, is it positive kind of like everywhere then? Like as long as it's.
Yeah. I mean, you could get a negative angle like south. No, not really. You'll just always start at the North or the South Pole, and then there will always be a positive angle telling you what direction you're going to move towards.
Okay.
So in
cool.
bearing method 2, you're also not going to have an angle that's greater than 90 degrees. Yep. All right, all good questions, you guys. It's not easy stuff, which is why we're going to practice with diagrams here. On your homework too, if there is no directions that state whether your final answer needs to be bearing method 1 or bearing method 2, then just pick the one that you feel more comfortable using as well. All right, so let's actually use these in an example, and then I'm going to give you guys the rest of the time to do your homework. Okay, so number 63, there's a space for you guys at the bottom of page 3 on your student note packet. It looks like this. We are told that we're flying in a plane and we leave Midway Airport from runway 4 right. Doesn't mean anything. Okay, whose bearing though is north 40 degrees east. So we're on a plane flying north 40 degrees east. So that's bearing method 2 there. And we're told that after flying for a half a mile, the pilot requests permission to turn 90 degrees and head towards the southeast. Permission is granted. After the airplane goes 1 mile, we want to know what bearing the control tower needs to use in order to locate the aircraft at that point. Okay, so here's what we're going to do. We're using bearings. So the best thing you guys can start with is just a set of X and Y axes, and we're going to label northeast, southwest on it. So go ahead and just construct that kind of right in the middle. And honestly, you guys, the bigger your diagrams are, the easier they can be to read. So if you are a person that likes to draw really, really small, it might put you at a slight disadvantage when you're drawing the diagrams and trying to figure out stuff. Okay. All right. So we've got our axes, we've got our directions here, northeast, southwest. And we're going to sketch the first piece of this problem. The first piece is this. Our airplane takes off from the airport. The airport is going to be here at the origin. And we travel a half a mile at a bearing of north 40 degrees east. So let's graph a half a mile leg at a bearing of north 40 degrees east. Might look something like this. Okay, and there are two things that I know here. I know that this angle is 40 degrees. And I also know that the length of this leg is a half a mile. Okay, stop me if there are any questions with setting this diagram up, you guys. From here, we're told that the pilot asks permission to turn 90 degrees, exactly 90 degrees, because that's definitely the real life. All right, and we are going to head towards the southeast. So 90 degrees towards the southeast. Well, southeast, you guys, is down here, right? Southeast. So we're going to move in that direction, but we're going to turn 90 degrees. So from the end of that half mile leg, we are now going to sketch a leg that is a mile at an angle of 90 degrees. All right, so here's where diagrams really matter. If you can draw your diagram to as much scale as possible, you are going to set yourself up a lot better for solving the actual problems. And I'm going to show you why in just a minute, okay? Our first leg was a half a mile. The second leg is a mile. So realistically, that second leg should be about twice as long as the first leg. Well, exactly twice as long as the first leg. If you guys draw a leg that is too short, right, not drawn to scale, you're going to end up in the wrong quadrant. Your final answer is going to end up in the wrong quadrant. It's going to make no sense. So draw to scale as possible, like as possible as you can. And I would say use a ruler. If you've got a protractor, it even helps you with the angles there. But we want our drawings to be as much to scale as possible so that we don't get diagrams that make it more confusing. All right, I'm gonna fill in what I know. I know that leg is 1 mile, and we were told that that angle between the half-mile leg and the 1 mile leg is 90 degrees. All right, this question though is actually asking us what bearing the control tower from the airport needs to use in order to locate us. So we are looking for from the airport to where our plane is now, that angle and bearing. So from the airport to where we are now, that's the hypotenuse of this triangle. Our final answer needs to be this angle. Okay. All right, Kayla, question before we go or start solving?
Yeah, so should we be using a protractor and stuff for all of this? Because I feel like if you don't, then you're not going to get in the right quadrant. So
It's up
just
to you. I think in person, when I do this every year, I always have a protractor handy. I think it's really helpful to draw the diagrams, but even a ruler can make a big difference. So
okay.
even if you have a ruler, it'll help you a lot.
All right.
Okay, so let's solve for this angle. Now, there's a few ways we could go about doing this. And like I said, you're gonna pick the way that works best for you. There are actually two ways we can express our final answer. So bearing method 1 measures from true north going down to that last leg, or we could use bearing method 2 as well to express our final answer here. The problem doesn't state which method to use, so pick the one you like better. Okay, I'm gonna go with bearing method 1. And the only reason I'm gonna do that is because I think it's easier to get the answer there. Here's the deal. This is my plan. I can find this angle theta, which is the angle inside of our right triangle. And if I find the angle theta, then our bearing in method 1 is just 40 degrees plus that theta. All right, so look at the diagram, think about that. It's a huge review of geometry here. But what am I told about theta? Well, I have a side length opposite, I have a side length adjacent, so we can use tangent here in order to solve for theta. The tangent of theta is 1/1/2. Side length opposite over adjacent. So theta is the inverse tangent of 2. We're just going to take our calculator, type that in. So the bearing that the control tower needs to use is at 63.43 plus the 40 degrees that we originally started with. So 103.43 degrees. All right, now I'm going to do one more thing here, and I'm going to also express this in bearing method 2 so you guys can see the difference. Okay, so bearing method 2 is going to start us at the South Pole going towards the east. It is in what we would consider the 4th quadrant. The 4th quadrant always starts at the South Pole, moves to the east. So in bearing method 2, we're starting at the South Pole, moving towards the east. We just need to figure out how many degrees towards the east we're going to go. So there's one of two ways we could do this, or there's a few ways that we could do this, but that degree there is just 180 minus bearing method 1. Right, use what we know from geometry about straight lines and things like that. So if I take 180, I subtract that 103.43. We start on the South Pole, and we're going to move 76.57 degrees towards the east. Either one of those two answers is good for me, right? The problem doesn't state which method to use. Pick the one you're most comfortable with.